Welcome to the Foundry by Forge College. Today, we're jumping right into our explainer on designing network configurations. This is a super important step in our Deploying Smart Contracts with Confidence course, which sits inside the broader Ethereum dev stacks and frameworks track. We're going to take those chaotic, messy deployment scripts and transform them into a structured, highly predictable machine. Let's get to it.
Okay, before we get too deep into the weeds, have you ever accidentally committed an API key to a public GitHub repo? Yeah. We've all felt that sheer cold sweat, that absolute panic of frantically revoking keys while just praying a scraper bot didn't drain your testnet funds. Honestly, we've all been there, or at least we know a dev who has. That heart-stopping moment, that perfectly sets the stakes for what happens with poor configuration. So, we're here today to make absolutely sure that never happens to you again.
Let's just quickly reorient ourselves. Right now, we're essentially connecting the gears after Turbine. In our previous explainer, Data Delivery Mechanisms in Turbine, we looked at the underlying systems of how data actually moves around. Now, our challenge is consistently connecting our deployment tooling to these networks and doing it without breaking things along the way. How do we make sure our tools talk to the blockchain perfectly every single time, no matter the environment? Here's our roadmap for today's explainer. First, the deployment dilemma. Second, blueprint anatomy. Third, building the template. Fourth, the validation inspector. And finally, ready for deployment.
So, kicking things off with Section 1, the deployment dilemma, preventing hard codes.
We have all felt the absolute frustration of a deployment crashing on, say, step 45 out of 50 just because of a tiny typo in an RPC endpoint or a missing environment variable. It's the worst. To fix this dilemma, we bring in our hero, parameterization. This is basically just leaving a blank slot for an environment variable to plug into later. Think of it exactly like a universal travel adapter. When you travel overseas, you don't rewire your laptop charger, right? You just plug it into an adapter that fits the local wall socket. Parameterization does exactly that for your code. It lets your deployment scripts run smoothly anywhere without ever hard-coding sensitive secrets directly into your codebase.
Moving right along to Section 2, blueprint anatomy, structuring our configs.
Okay, the golden rule here is that identical client configurations across networks drastically reduce nasty surprises. You want your local tests to behave exactly like production. On one side, we have your local environment. It's safe, it's predictable, it connects directly to your local host. But contrast that with public testnets. Those are gated, they're heavily rate limited, and they almost always require API gateways and authentication keys just to say hello. Your master blueprint needs to be flexible enough to handle both of these realities gracefully.
And that brings us to our actual spec sheet. We've got 6 mandatory fields required for each environment. First up, the endpoint. Where exactly are we sending the data? Next is the chain ID, that numeric identifier telling us which network we're actually on. Then timeout MS. Basically, how long do we wait for a response before we just give up? Then we have our retry policies, retry attempts, and retry backoff MS. How many times do we try again, and how long do we pause between those tries? And finally, APK in V, which is the name of the environment variable holding our secret key. These specific parameters are the dials and switches that control exactly how your tooling negotiates with the blockchain.
All right, Section 3, building the template, drafting configuration.
It is time to put on our hard hats. We start by initializing our workspace, installing AJV for JSON validation, and grabbing .env for local variables. Next, we draft our networks.yaml file. We are explicitly building entries for 3 distinct environments here just to prove our flexibility. We've got our local environment running on localhost, chain 1337. Then we have testnet A, which is a fast public testnet on chain 420. And finally, testnet B, a gated API testnet on chain 133. Setting up this structure ensures our deployment runners know exactly how to handle totally different deployment targets.
I really want you to burn this exact phrase into your memory. Separate environment-specific values from reusable provider settings. This is an absolute core best practice taught across the various Web3 learning programs here at Forge College. And why is it so absolutely crucial? Well, because it inherently prevents accidental secret leakage. Your timeout settings and retry logic, those can be safely shared and committed to your repo all day long. But your API keys and specific gateways, keep those separated, keep them far away, and inject them only at runtime.
Which brings us to Section 4, the validation inspector, checking the blueprint.
Drafting a blueprint is great, but we need an inspector mechanism to make sure it isn't completely flawed. So here's the underlying logic for our validate config.js script step by step. Step 1, we parse and load the networks.yaml file using js-yaml. Step 2, we rigorously check the schema using AJV to make sure all required fields actually exist and are formatted properly. And step 3, we resolve any sensitive values against process.env. This step-by-step approach is brilliant because it turns silent, sneaky configuration errors into early, loud, actionable failures right here in the script, rather than waiting for our deployment to just crash halfway through.
Let's zoom in on the specific JSON schema guardrails we've set up. The chain ID must strictly be an integer. The endpoint must be a string. The retry object? Absolutely mandatory. An API env is set as optional, mostly for those local networks that simply don't need it. I always have to laugh at this part, because passing a string where an integer was expected is basically a developer rite of passage. Come on, we've all typed chain ID 1337 in quotes and spent 3 hours wondering why the compiler is screaming at us? Well, these guardrails prevent exactly that kind of headache.
And this brings us to the ultimate, undisputed, golden rule of Web3 security. Your .env file goes in .gitignore. Keep secrets off the blueprint. Literally never ever commit your .env file to version control. Let your automated continuous integration pipelines inject these secrets at runtime. Think of it like this. Your blueprint should just be the treasure map. The .env file, that's the actual treasure chest. Do not leave the chest lying around for the whole internet to find.
Finally, Section 5, ready for deployment, the final testing phase.
Now we run our validator against both perfect and intentionally broken entries just to see if our guardrails actually hold up. The absolutely crucial point here is how we communicate these failures using standard exit codes. Exit code 0 means, hooray, configuration validation passed, proceed with the deployment. Exit code 2 means you've got schema validation errors, like maybe you forgot to include your backoff MS value. And exit code 3 means resolution errors, meaning your required environment variables are completely missing. By omitting these specific exit codes, your continuous integration systems can instantly interpret failures, halt the pipeline, and keep bad configurations far, far away from the blockchain.
So I'll leave you with this question. Is your master blueprint ready to be handed over to the deployment runners? Because if you have followed these parameterization and validation steps, it absolutely is ready. And honestly, that sets us up perfectly for our next explainer, Validating Deployment Environment Readiness, where we are going to take this beautifully validated artifact and plug it directly into a simulated CI pipeline. Master blueprint complete. You've definitely earned this one today. Congratulations on building a robust, reusable network configuration system from scratch. You are now one massive step closer to deploying smart contracts with absolute confidence. I highly encourage you to visit forge.college to explore more content, dig deeper into this subject, and check out all the other Web3 learning resources we have waiting for you. Keep exploring, keep iterating, and as always, keep building.